ships release invisible contrails that slightly cool the climate. The effect of aerosol pollution from shipping and other sources on clouds has been underestimated and may need to be factored into future climate models. Ships release aerosol particles of air pollution as well as greenhouse gases. Streaks of invisible air pollution from the world's shipping industry, which are unseen on satellite imagery, are changing the reflectivity of clouds. This means clouds exposed to air pollution from all sorts of sources may reflect more of the sun's light and heat than we thought, which will have to be taken into account for future climate models. The effect of this air pollution doesn't negate the effect of the greenhouse gases also released, however. Clouds play a complex role in the climate. Depending on how high they float in the atmosphere and their composition, they can either contribute to or detract from global warming. Understanding their interactions with the environment is crucial for accurate climate models. Pollution from aerosols, fine particles suspended in air, influences the formation and properties of clouds. The climate warming role of the greenhouse gases in shipping emissions is well established, but less is known about the aerosols. Previous studies looking at the aerosols from ship funnels have used satellite imagery to assess their effect on clouds. Some are clearly affected, but many more clouds appeared unaffected. Peter Manshausen at the University of Oxford and his colleagues have found that clouds that had appeared unaffected are in fact changed by the aerosols. The researchers mapped the paths of 2 million ships in the Atlantic Ocean over a 6-year period and used a global database for the winds on the trade routes the ships traveled along to see where their emitted aerosols would go. They then used another database of cloud properties to see how these clouds were affected. At the locations the researchers predicted the aerosols would travel to, there were tracks of clouds with fewer droplets but more liquid water. This slightly changes the overall reflectivity of the clouds and, more importantly, a larger water-to-droplet ratio implies a stronger cooling effect, so the clouds would reflect more radiation back towards the sun. It's really compelling. It's an area that would have been neglected by other climate modeling groups. We do largely focus on the stratocumulus regions, rather than cumulus, because in the pre-industrial times, there were a lot more stratocumulus clouds. As we get warmer sea surface temperatures, there's going to be, it seems like, less stratocumulus and more cumulus. The work doesn't mean, however, that the emissions from ships have a cooling effect overall, says Manshausen. The emitted greenhouse gases will still warm the climate, while the emitted aerosols have a smaller cooling effect.